Hey, what's up everyone and welcome to Daily Code Buffer. In this video, we are going to learn about generics in Java, why we do need generics and how generics help us in a lot of ways. So let's see generics in Java. Before that, let's take a simple example and try to understand at which particular point we will be able to use generics and how it helps us. So here you can see that in my screen, I have created one generic example here and I have a main method here. Now suppose for the example I just need to have the different counters available based on the different data types. So I just wanted to have an integer counter, so let me just create the integer counter. So I'll just create one class, create new class, and I'll just say integer counter. Okay, so this is a simple class that I have created, and here in this I'll create one property that will hold the integer value I. And for this integer counter, let me just create the constructor in which we will pass this integer. So here I'll just create integer counter, and here I'll pass the integer, and I'll just say this dot I equals to I. Okay, and for this I'll create one method to print this counter. So I'll just say public static void print s out this dot I. Sorry, rather than static, I'll just make sure that it's public void print because we will be calling this based on this object. So here you can see that this is a simple integer counter I have taken over here, and this integer counter is nothing but holding the integer value, that is integer I. It has a constructor. With the constructor we are able to pass the value, and it has a print method which is printing this I value over here. Now if I go to the generic example.java, in the main method I can call this class with integer counter int counter equals to new integer counter, and here I can pass integer value as 1, and I can call integer counter dot print this value, and if I run this I should be able to run this particular program and I should get the output as 1. Simple class. Now rather than having the integer, I need to pass the double value, okay, as the counter. So what ideally I would be doing is, if I go to this integer counter here, I just have this integer value. Okay, so what I can do, as I need to store the double value, I can create a double counter class. I can create the double placeholder and pass the value. So if I suppose do that way, let me create the class double counter, and let me just copy paste all this thing. And instead of integer counter, I'll just rename to double counter. Okay, this class is ready. It is just having the double value here, double as I, and in the parameter also we'll be taking the double, and we are just going to print that value. Now if I go to the generic example here again, and if I do double counter d counter equals to new double counter, and I'll just pass the value 1.0 because it's a double value, and with d counter I can call the print method, and if I run this I should be able to get the result. You can see that I'm able to get the result. Now if you see here, we are just doing the same thing. We are just printing the value at both the places. You can see that both the classes are almost similar, just the data type we are holding is different. This is the integer counter, which is having the integer as the property where we are storing the integer. It has a constructor and it has a print method. Same for the double counter as well. It has a double value, double property, which is having the constructor, and we are using the print value. Now at this particular point, you can see that this method is very simple. Classes are very simple, but what if you have a huge classes and all those classes are doing the same thing, but those are different based on the data type that you are using? So for those purposes, generics is something that we can use. Now let's talk about internet security. With more than 5200 servers, amazing speed and one-click connect, NordVPN gives you the best features and security. As a techie, we know how much important it is to secure our data and identity. With NordVPN's diskless servers and end-to-end encryption, everything is secure, which routes via their servers. So no one will know your IP addresses. And if you want, you can route through 2 VPN servers to double down on production. And also it enables all the content on Netflix or Amazon Prime. You can just change the server and the content or your favorite shows available on that location will be available. I use NordVPN on all my devices. So if you are interested, go to this link or use the coupon code DCB to get a 2-year plan plus a bonus gift with a huge discount. Now back to the video. So let's the same example where we can use the generics. So we have these two classes. Let's create a simple counter here. So I'll just create a new class and I'll just say this is a counter. Now for this counter, what I'll do, let me just copy this. Okay, I just need this print method, I just need the constructor as well, and I just need this property as well. I'll just copy this, go to the counter, and I am just adding all the values here, all the data. Now I just need this counter constructor. Now what I want for this particular class is to handle all the different types of data types. As this particular class is very unique, it is just doing the counter and printing those values. But I want that values to be printed for whatever data type that I am passing here. So rather than hard coding the data type which I am doing over here, what I can do is I can define the type, and that particular type needs to be passed by the calling class. So suppose this counter, I can define this counter can take any type this way, and here rather than t you can write any value. You can write abc, xyz, whatever you want, but the same thing you need to use at the every places whatever you have defined here. Ideally in the Java, for the type t is defined, so we will go ahead with that particular approach only. Now as you have defined that this particular counter class, it will be taking the type t over here. So that means whatever the type that we have defined, whatever the type that we are going to pass, that's the only thing we are going to define here as a t. Rather than defining integer, double, string, whatever we want to use, we will define what particular type we are passing. So whatever type we will be passing in a particular counter, that type we have defined, and the same type we will pass in our constructor also. And this dot t equals to whatever the t we have passed here. And for printing p as well, in the print method we will pass t. We are going to print t here. So you can see that we have just simply converted all the different classes that we had, like integer counter, double counter, we converted to a counter class which will take the definitive type that we are going to pass. Now let's see with the example how we can call this. So if you go to the generic example, earlier we used to call this way, right? Now for the counter class, how we will do is counter we will define, and here we need to define the type, and we will define in the angular brackets and what type we want to pass. Suppose I want to pass the integer, so I'll define integer and I'll define iCounter equals to new counter, and here I'll pass the value. And you can see that when you are calling the constructor, you just have to pass the diamond operator. Okay, now if I call iCounter dot print, I'll be able to print this value. So if I run this, you can see that I'm getting 1 over here. Okay, I'll just remove this code from here so you will able to see better. If I run this again, I'll be getting 1 here. Now let's do the same thing for double. If I pass counter of double, d counter equals to new counter, and here I'll pass 2.0 as a double value and d counter dot print, and I'll run this and it should run completely fine. You can see that I'm able to run both this particular types here, and here you can see that we just only define what particular type this particular class will be storing the values, and all this type will be passed over here as a t. Now one thing we need to make sure that whatever the type we are passing here, that has to be a wrapper classes or a class. We cannot use primitive types here. So if I just pass primitive type here as an int, you can see that we will get the error that type argument cannot be of primitive type. So all the classes only we can define here. So rather than integer, let me just define string as well. I'll be able to pass the string as well. Rather than 1, if I define with 1, I should be able to print this as well. Whatever class you can define, you can pass those classes. Now the other thing we can do within the generics is we can bound the particular class as well. So suppose if I go to the counter, and here we have defined the t here, that means any class we can pass, but I want that particular class to be bounded. I can do that as well. Suppose within this, as this is a counter, I just want that all the number classes only it should be part of. So what I can do is I can define that this particular t, whatever the type that you're passing, that should extends number class. Okay, so that means now we have restricted for this particular counter class that it can only accept all the number classes, okay, which is part of a number. So that means if I go back again in the generic example, you can see that I'm getting the error over here in this string, and it says that type parameter java.lang.string is not within the bound, should extend java.lang.number. So whatever the class is that has been extending number class, that only we can use here. So I can use integer, I can use double all those classes I can use. So that's how we can bound those particular values as well, like which particular classes are been extending. Now within this counter, you can see that within this, if I go again, we can also bound multiple interfaces also. So suppose if you want to bound to particular interfaces, like if this particular class is implementing this interface, then only I want to allow those. So rather than number, let's take the example of the interface that is serializable. So suppose I want the type T that extends serializable. Okay, so here rather than class, I have defined that interface over here rather than the class, right? So that this also should work fine. And here when you are using interface, that also will come with the extends. Your implement should not work. So it is extending this particular serializable. And now when you have multiple interfaces, you can go ahead and add multiple interfaces with AND operator. And you can also add the class with the interface as well. Suppose T extends number and it also should extend serializable. Okay, so this is the interface, this is the class, and class should always comes first in the sequence. So you can only extend one class, but you can extend multiple interfaces. If I give this number here at the end, it will throw the compilation error. Okay, you can see that move bound number to the beginning of the bounds list of type parameter T. So this number should always be, so whatever class that you are defining, that class should be first and then followed by all the interfaces. So this way you can define like this particular counter will extend the numbers, will extend the type. Those are numbers and those also implementing serializable, and this should work completely fine. I'll just remove this one here because it's a number. Okay, it's completely working fine. Now you would have come across using generics in all the collection frameworks. So whenever you are using collection frameworks, you will be using generics. So suppose let's take the example of that. If we are using the array list over here, and within that array list, you would be defining the type of objects or type of classes that you want to store the data. Suppose within this array list, I want to store the integer values. So you will be defining generics here, integer, and I can define int list equals to new array list. Okay, and here within this int list, you will be able to add those values. Int list dot add 1. So this way you will be able to add those values. Now you might say that, okay, within the list, I want to store the objects. I want to store the integer, double or string or whatever it is. Why we need the generics here, right? So suppose if you say that, what you can do is you can say, okay, I can directly store the objects because all the classes are of type object. So if I change that way, if I go ahead with that argument and I change this object here, that means I'm able to store this integer value here. Okay, and I'll be able to also store string value here. Both the things I'm able to do here. And whenever I want to take this value back, suppose I want to take the value, then what I can say, I want the integer value because this is my integer list and I'm supposed to add the integers in this list. And I can say integer I equals to int list dot get 0. If I do this, you can see that we are getting the exception here that cast to java.lang.integer, because this is of type object and Java doesn't know that this would be coming as the integer. So what I have to do is I have to explicitly convert this to integer value, because I know that this list is for integer value and I'll be storing the integers. So if I do this, then there is no compilation error, everything is working fine. So here you can see that as I have defined the type object here, I've also added the string here. Okay, and whenever I try to get that particular thing, first value, and I'm converting to integer because I know that this is an integer list and I'm supposed to add the integers only. But anyhow, by mistake, as I have added the object, I can add the string as well. It won't throw me any error, but when I run the application, it will freak out. You can see that it is throwing the error that class Java string cannot be cast to class integer, because this string cannot be casted back to the integer value. So it is very important to use a proper type that you are going to store those values. Suppose if I'm just storing the integer, it's beneficial to use those particular types. And what other thing it helps us is that you don't have to cast those values as well. It knows that this is going to store the integer, and whatever other values you're going to store, it will throw the error as well. That you can see that string cannot be added, it's of type integer only required. So I can change those values and everyone will be happy here. Java will be happy and you will get a direct value as well. You don't have to cast those values. So this will work completely fine. Now we added the generics in the class, but we can use the generics in our methods as well. So let's go and see that as well. Let me just remove everything here and let me just create one method, private static void print method, which should take any generic value. Suppose I'm defining that it should take any t value of any type and it should just print that value t. Okay, now you can see that this method freaked out, right? Because it doesn't know what is t. So we need to define this type t within this method before the return type. So before the return type, we can define that t is defined and t will come as any of the classes, and whatever the classes we can pass over here, that we can define. Suppose now I can call this method print and I can pass one. With this print again, I can pass string as well. Okay, and everything should work completely fine. You can see that everything is working fine. Now suppose if you have multiple values, right? Suppose multiple parameters, and all those multiple parameters are also has to be defined using the generics. That also you can do. Suppose I can define another parameter this way, and this parameter you can specify your after in comma separated value. So t is also defined and u is also defined. So both this value will come, t and u, and I can print those values. Okay, I can pass 1 and 2, and I can pass Shabir and Daudi. So it should work completely fine. Okay, you can see that everything is working fine. The other thing we can do over here is we can also define the return type. So suppose rather than return type void, I just want to return t here, I can define that my return type would be t, whatever the type is defined, and I can return the value of type t. So let's just return t here. It will not throw any exception. So this way also we can define the generics. It will also completely work fine. Now we can define within the list as well. So let me just give you an example. Let me just create one more method. Private static void print, and here I'm just taking the entire list object here. Okay, and this example will show you the wildcard characteristics of the generics, how we can use the wildcards in the generics. So suppose I'm taking the example of a list. Okay, and this list will take whatever the values that are defined, suppose any type. Okay, and what I'm doing is I want to just print that list. So I'll just define as out and I will define print list. Now as you can see that I have defined the list here, and this list is of type object. That means ideally I just want to pass any classes or any object or any list of type any class, and that I just want to print. Okay, so what I'll do, I am just taking the example here. I'm just creating the list here and I am passing integer. I'm creating the integer list equals to new array list, and in the integer list I'm just adding 1. Okay, I just created the list here. Now I just want to print the list and I'll pass the int list, and here you can see that you are getting the error as list of object is not equals to list of integer. Okay, but and as we know that integer is the subclass of object, but list of integer is not a subclass of integer, sorry, list of object. So that's why these are different. But what I want to do is I want a method that can take the list of whatever type we want to pass. Okay, either it would be a list of string, list of integer, list of a double, list of any custom class as well. Anything it should be able to take and print those values. Okay, and as we cannot use object here, that's the wildcard character we can use. So rather than using the object here, what we'll do is we will use the wildcard character, that is question mark. Once we define this is a list of question mark we are going to take. This is the anonymous, we can take anything. Now you can see that the error won't be there because it will be able to accept this, and it should be able to print as well. You can see that we are able to print as well. So this is how we will be able to add the wildcard characters as well. And within this wildcard characters as well, for this particular wildcard character, we can also define the bound values as we had defined in our counter here. So this also we can define that this particular wildcard, whatever we have defined, all the classes which are going to pass, that should be bounded to numbers. That means whatever we are going to pass here, that has to be number. So suppose this is integer, so there is no error, it should work fine. But if I change this to string, okay, list of string here, and I'm going to pass 2, then you can see that it will still throw the error that required type is wildcard that extends number, and you have passed string doesn't extend number. So this way you can define the bounding as well within those generics and wildcard characters. So this is a general idea about generics, and it is widely used at all the places, mainly in the collection framework. So you should go through the generics and you should learn about generics. It's a highly advanced topic and asked many times in the interviews as well. So when you're preparing for the interview, this topic will help you a lot. If you have doubts regarding any of the topic that we have covered, then do let me know in the comment section below. I will try to solve that as soon as possible. If you are enjoying this content, then give us a thumbs up and subscribe to my channel for the upcoming videos. You can also join the channel by clicking on the join button and support the channel. And I will see you in the next video. Till then, happy coding. Bye bye.